FakeBuster can be embedded into enterprise workflows where fact accuracy is critical. News organizations can use it to verify breaking stories in real time, reducing editorial risk. Financial institutions and risk analysts can validate geopolitical claims before acting on them. Whether in investment reports or due diligence checks, government agencies can integrate it to assess the credibility of foreign policy developments and media narratives. Meanwhile, social media platforms and content moderation teams can automate the detection of AI-generated misinformation at scale. With its source-grounded answers and audit-ready output, FakeBuster brings verifiability into environments where compliance, speed, and trust all matter.
Hello everyone. After that introduction, let us get into the next section. In this section, I'm going to explain how FakeBuster, the idea, was invented, how we have built up the code, give you a walkthrough of the final notebook. Firstly, I would like to say that this idea is created and this notebook is created for the 5-day Gen AI Google Capstone project, and this is idea and the notebook is created by myself, Noel, Adamya, and Himanshi, who are the collaborators and my teammates for this project. Let us dive deep into how did we come up with the idea of FakeBuster. As we had to build this project using Gen AI, we wanted the idea and the use case to be relevant and solving a real problem which would sustain in a future point of view also. That's when we were just discussing about what kind of different problems that we are facing, wherein we came across the latest news that of the tariff that is going on. And personally, I also have been experiencing a problem with a lot of news being bombarded over social media, various blogs on the news, and with the challenges in the ups and downs in the stock market, with so much volatility. It was a very difficult situation to get the news and understand what is the right news, what is not the right news, what could be a potential uh, correct news, and all these kinds of confusion. So we thought that with the help of the large language models and the RAG pipeline, we should definitely be able to solve this problem. And that's how FakeBuster, Get Your Facts Right, was invented. Let me quickly dive into the notebook to give you all an overview of how we have built this out and what all technologies we have used. So as I mentioned that FakeBuster is powered by a RAG architecture, and we are using the Google Gemini 1.5 Pro model for this implementation. We are using the ChromaDB for as a vector database. We have also integrated Google Search API, which keeps the project relevant for the future use case and also is able to handle any anonymous or any kind of web search to get the grounding correct and also cite the sources from which it is getting the results. We have also introduced the context understanding with the help of creating a context cache, which basically helps the model to understand and keep all the previous answers in memory while processing the final answer for the user. We have also introduced the AI evaluation section in this notebook, which helps us to understand how the model that we have created is answering the questions, and we are able to fine tune the model and edit the prompts accordingly so that it will be better as the development continues in future. Firstly, we'll have to install all the required packages using this command. On the right hand side, as you can see, there is a table of contents that we have created on this notebook. So we'll be walking through this quickly. Next is to set up the required API keys. So we would need the API key for the LLM. We need to create a search engine ID for Google search, and we are using the Hugging Face uh, library to for the AI evaluation, in which we are using the Mistral AI for the evaluation point of view, which we will see later. So in this section, you can see we have given all the steps and the links to how we can generate all these API keys that is required and use it in the project. Once you run this code, the API keys would be uh, coming in. You can always go to the secrets if you're using the Gaggle notebook inside add-ons and enable the API keys if not. Next, as we mentioned that in the ideation of this project, it started off with the various confusion that we were having for the tariff. So we tried to create a sample data set for this project where all the news related to the tariff and various trade policies and any other geopolitical issues that were going on. We just tried to we created a sample data set which we would be using uh, to put it in our vector database and create a RAG model out of it. So as you can see that the database we are converting into the document for document understanding and which will be used to put it in the database in the vector DB. Over here, it is important to note that we are adding a metadata also along with the which is the source over here. So this will help us to retrieve the source separately while in the retrieval process of the pipeline. In this scenario, you can add another metadata as per your business use case, which will be helpful. Uh, while creating the documents in the rack pipeline, we usually chunk the data and then embed the data into and store it in the vector database. So over here we are use the recursive character text splitter, which is an advanced technique in order to optimize the sampling that is done or creating the chunk size rather than just simply splitting the data into chunks randomly. This is an advanced technique that can be used. Similarly, BERT based semantic understanding and uh, markdown specific, if in case of PDFs, chunking can be done in order to increase the quality of your embeddings. In this section, we would be setting up our LLM and the rank chain configuration. As you can see, we have set up the uh, LLM using the LangChain library for orchestration, in which we are using the Chat Google Generative AI to set up our LLM, in which you can see that we have given it a system message so that it has a clear idea of what it has to do, what all are the different functionalities that it can use, and how it has to provide a better answer. Over here we are using two tools as I had mentioned earlier. One is a GeoNews DB, uh, which is going to be the tool to fetch data from our vector DB. The second one is Google Search, which is going to help the model to do real-time search updates using the Google's custom search API. In order to enhance the tool functionality, we have created a tool wrapper. So the tool wrapper basically can be used in various ways as per the business use case. In our scenario, we have used it to ensure that a particular tool is called only once. This reduces hallucination. At the same time, it also is passing over the context from the previous tool search uh, and asking the model to generate the output. As you can see over here, this is the first tool search for getting the documents from the RAG chain, which is basically our vector DB. And we are also using this last tool sources to cache the data that is retrieved from the vector store, which can be used later on to generate all the metadata and do all the filtering that is required. And this is our second tool, which is the Google search tool. We have specifically chosen the React prompting and the React agent style for creating the agent. The reason being that as for this use case, we are required the the agent to think thoroughly and then get the information, and if required will perform uh, actions like doing Google search and generate the final answer. So for this section, we have also done the few shot prompting, in which we have clearly provided the tools in the prompt. We have asked them the guidelines, set specific guidelines to not hallucinate, to give extract all the relevant information, do not call the tool again, and always use the observation to form the final answer. As a part of few shot prompting, we have provided 4 to 5 examples in which uh, we have we have explicitly called out the React styling of prompt, where the question, thought, action, and the observation uh, steps are mentioned. Providing minimum 4 to 5 prompts would be uh, is recommended for the few shot prompting with various variety of examples. This kind of prompting also helps us to handle different kinds of edge cases, if so in the model use case, to help the model perform better. Since we are using the cache, we have set up a function to clear all the use tools and clear the cache before each agent invocation. Finally, in this you can see in this section that we are taking a particular query and we are invoking the agent and generating the final response. In the invocation, you can see how the question, the thought that the agent is taking, and how it's intelligently understanding where it can take the information from. In our prompting, we have clearly mentioned that if anything is before the present date, then it should first always check the vector DB, as we constantly keep updating the vector DB with the latest news. And in case it's not able to find a proper conclusion with the information in GeoNews DB, or if the request is for a future date, then it has to do the Google search and generate the final answer. So once the answer is returned, you can see that we are also from the cache that we had created, we are fetching the metadata using from the metadata we're fetching the source, which is nothing but the URL, and in the final answer that can be presented to the user, we'll be having the summary of the agent's understanding as well as the sources that it has used while making the search to generate the answer. So this was all about how we have created a RAG model and uh, providing it the intelligent functionalities of accessing the vector database and doing the Google search. Next is of the AI evaluation. In this section, as I had mentioned earlier, we are using the Mistral model of Hugging Face. So we just install the required packages, import the required libraries, and similar to the initial step, we do create a document of the dataset. So we are using the contextual uh, uh, way of creating synthetic questions for evaluation. So we are giving the same dataset that we have created, and using the Mistral model, we are generating the more questions as an evaluation, which will be used for evaluating the responses of the agent. So Mistral AI is pretty popular and has a powerful is a powerful tool for evaluation agents. Uh, so we are using that, And as you can see in this section, we are generating the sample question and answers. So we have created this prompt in which we are asking Mistral to generate the question and answers. By changing this variable, we can generate how many ever question and answers we want for our evaluation. It is generally uh, kept to a higher number, but just for the performance and cost considerations, we have kept it for two at two. So once the Mistral model is generating the questions as well as it provides the context and also gives us the source document based on the prompt that we have created above. If you can see the next what we have created in order to evaluate these prompts in a way, we would be setting up certain criteria. After creating the set of questions, synthetic questions for our evaluation, we also need to define some quality metrics to evaluate the generated question uh, and the context analysis. So for that, we have created these uh, three criteria. One is the groundedness in the prompt. The second is the relevance, which would be checked, and the standaloneness in the answer, in the final answer. We generate the ratings between 1 to 5 for each of these, and uh, it would be providing the rating for each of the three metrics. Uh, in this section, we are generating the metrics by calling the LLM model, and as you can see in this section for the generated questions, we have populated the particular metrics. In some scenarios, as you can see over here, the model outputs not a number as uh, the scores. In such scenarios where some data cleaning and reprocessing is required, we have introduced a filtering section in which, depending on the score, and we are able to filter out the quality data at the same time cleaning out any uh, issues within the data set that's created. So depending on the business use case, you can select what kind of filtering criteria uh, has to be defined, and then we get the final data set that can be used to evaluate our existing model. So in this section now we will be evaluating the model. As you can see, the agent that was created earlier is called, and we are providing the question from the evaluation dataset that we have created, and the answer is generated for us. uh, the answer is generated, and it's stored into the dataset. So this is the generated answer which is created by the Google Gemini model API. In the evaluation chain that we will create in this section, you can see that we are using the same model, that is Gemini 1.5 Pro, for evaluation or acting as a critic for the main for the generated answer. It is possible to use any other model also for the evaluation as per your use case or choice, as it is also possible to use multiple models to enhance the accuracy of the evaluation and work on it accordingly. The three criteria that are mentioned is given to the evaluator and with the model, and the final evaluation is created and stored into the data frame. And as you can see in the final evaluation, we get the correctness, relevance, and consciousness related information which is given to us, and also a final score would be provided to us. In conclusion, this model is ready to solve all the problems exist and clear all the confusions with a realistic database and uh, evaluation specific models and techniques to be enhanced. This can become the go-to solution and the go-to application to solve any misinformation and provide relevant context to everyone and anyone uh, in the world.